Hello everybody, I am Professor Imran Sayyed, Electronics and Telecommunication Department with Dalankar Polytechnic. Well, I am here today with my video on Programmable Logic Controller, famously called as PLC, and its role in the field of automation since its inception. Well, the question is, did automation exist before PLC could hit the market? And the answer is yes. However, the components involved and the circuitry associated with it would make it look more complex. And if at all there was any problem in the circuitry, it would take a mammoth task for the supervisor on the field to troubleshoot the same and fix it. By the time the issue was resolved, the production of the industry would come to a standstill and it would hit the roadblock. In order to avoid this scenario, in the year 1968, a new programmable controller started shaping up. Since 1968 till date, this programmable controller, famously called as Programmable Logic Controller now, has seen a major phase shift. It has added several features to its kitty, and because of this, it has outplayed almost all its predecessors that were used in the industry. In this particular video, we'll be talking about definition of PLC, role of PLC in automation, advantages of PLC, block diagram of PLC and the components of PLC, PLC characteristics, different modes of communication that the PLC would use to communicate with the programming device, and selection criteria of PLC if a person wishes to buy it and use it. Along with this, we'll also see a sample video of automation where PLC is involved. Keep watching. Let's start with the definition of programmable logic controllers. A digitally operating electronic apparatus which uses a programming memory for the internal storage of instructions for implementing specific functions such as logic, sequencing, timing, counting, and arithmetic to control through digital or analog I/O modules various types of machines or process. Now something about the PLC that we need to know. A PLC operates at a very low voltage and yet it can communicate effectively with high voltage devices. PLC was basically designed keeping in mind industry standards, and hence the input and output devices connected with it are expected to be in a standard range. Field devices, that is nothing but input or output, are connected to the input and output modules of PLC, and these modules are optically isolated from PLC processor, thereby avoiding the processors from being damaged. PLC works on a relay logic, yet it does not require bulky relays to be physically connected to it. It has relay contacts at the input and output side that are turned on and off based on the sensors connected and the program written in the ladder logic. Both discrete and analog input and output can be connected to the PLC. The input and output modules of PLC converts the input and output signal that is compatible with the PLC. Power supply of PLC has an integrated SMPS which takes a 230 volt AC supply and produces low voltages required by different internal components of PLC like the processor, memory, and other system components. DC voltage applied to the digital input of a PLC is expected to be less than or equal to 24 volt DC. The AC input applied to PLC has to be within the specifications provided by the manufacturer. On applying signals in desired range, the input and output modules takes care of further signal conditioning, thereby avoiding extra signal conditioning required. Need for PLCs. Well, keeping into mind the requirement of the industry, a PLC was required to reduce complex circuitry of entire system, to eliminate the high cost associated with inflexible relay control systems, to get maximum efficiency from machine and control them with human logic, to reduce human efforts. Also, if required, replace human beings in working in areas which could be hazardous or at times difficult for a human being to operate. Advantages of PLC. Advantages of PLC are the reason why PLCs are so famous in the industry. It involves less wiring. Wiring between devices and relay contacts are done in the PLC program, which means there is less of wiring hassles. Since the wiring is done in the program, hence it is easier and faster to make changes. Troubleshooting aids make programming easier and reduce downtime. Well, it means the ladder diagram is associated with a compiler. If at all there's any problem with the wiring connections in the ladder diagram, the compiler does send a signal to inform the programmer that there is a problem with the program. It reduces the downtime. Compared to other microcontrollers, it can interface and control large number of I/O devices. Unlike other digital controllers, it has timers and counters in form of instructions, which means it does not have extra pins for timers and counters. The timers and counters used in program are absolute instructions. It could use as high as 256 timers and 256 counters for one project. Reliable components make these likely to operate for years before failure. Evolution of PLC. Well, programmable logic controller, the concept started off in 1968. However, in 1969, a hardware CPU controller with logic instructions, 1 kilobyte of memory, and 128 input-output points was introduced into the market. In 1974, use of several multiprocessor within a PLC, that is, separate processors for timer, counter, and arithmetic operations was introduced. It also accommodated an updated 12 kilobyte of memory and 1024 input-output points. In 1976, a remote input-output system was introduced. In 1977, microprocessor-based PLC was first introduced into the market. That is, one microprocessor with several features was available then. In 1980, intelligent I/O modules developed, enhanced communication facilities, enhanced software features. Well, it included documentation in software form. Also, feeding the program to the PLC was done through personal computers. 1983, low-cost small PLCs were introduced for the use of small-scale industries, whose requirement for the input and output was low. In 1985, networking of all levels of PLC, computer, and machine using SCADA software was possible. Well, SCADA means Supervisory Control and Data Acquisition System. Well, it simply means that there was one computer which could communicate with different PLCs simultaneously. At the same time, it could also keep a record of all the PLCs connected to the system. PLC classification. PLCs are available in variety of different ranges and sizes. But for simplicity, the PLCs are classified into two categories. They are fixed or compact PLC. Under fixed or compact PLC, there are two types, Pico PLC and Micro PLC. Pico PLC has 12 input-output points and Micro PLC has 32 input-output points. But other than this, compact PLC basically means it is one unit which has integrated processor, power supply, memory, input module, and output module. Everything integrated in one unit. The second type of PLC that was available was Modular PLC. In the figure, we can see that there's a separate module to the left. This module consists of processor, memory, and power supply. And the input and output modules are connected separately, which is visible in the figure to the right hand side. The benefit of having a modular PLC was, if at all there was any problem whatsoever with any of the module individually could be simply replaced, and hence the entire system would never come to a standstill. Modular PLC was also divided in subcategories based on their sizes. Small PLCs could accommodate 32 to 128 I/O points. Medium PLCs could accommodate 128 to 1024 input-output points. Large PLCs could accommodate 1024 to 4096 I/O points. Very large PLCs could accommodate more than 4096 I/O points. Well, it could go as high as 8192 I/O points, which was way too massive compared to any other controller that could be used in the industry. And so PLC was famous since its inception till the date in the industry. Let's start with the block diagram of a PLC. To begin with, a processor, power supply, memory, which has two sections, system memory and application memory, input module. This input module is connected with processor with an optical isolation, and the field devices are connected to the input module. This optical isolation keeps the processor safe from the field devices. The way there's an optical isolation at the input side, so does the PLC have an optical isolation at the output side. That is, there's an optical isolation between the output module and the processor, and the output devices are connected to the output module. Then there's a programming device. Well, programming device is one device which is used to feed the ladder diagram to the PLC. Now let's study all the components one by one. We begin with central processing unit. The CPU controls, monitors, and supervises all the operations within PLC. It also carries out programmed instructions stored in the memory. The CPU solves the user program logic by using real-time input status from the input modules and updates the status of output through output module. The CPU consists of a processor and memory. Processor happens to be the brain of PLC, as in the processor is responsible for the complete program scan in PLC. During program scan, processor communicates with the memory for the following operations. First, understanding the status of input device stored in memory. Then, to get certain numerical data stored in data memory to execute an instruction. And third, to write status of certain output device after saving program logic into output status file. Well, it means if you have inputs and outputs connected to the PLC, the moment you operate any one of the input, this is scanned by the processor, and the information about the input device is updated in input status file. On execution of the program, this information of the input status file, and depending upon the ladder logic written, the processor sends a signal to the output status file, and from the output status file this signal is sent to the output device, which is connected to the output module. Memory of PLC is divided in two parts: system memory and application memory. Let's begin with system memory. Well, system memory includes an area called executive, composed of permanently stored programs that direct all system activities such as execution of the user's control program, communication with peripheral devices, and other system activities. The system memory also contains the routines that implement the PLC's instruction set, which is composed of specific control functions such as logic, sequencing, timing, counting, and arithmetic operations. System memory is generally built from read-only memory devices. Well, it means system memory is loaded with a firmware. This firmware has instructions to run a PLC. At the same time, it could also have diagnostic programs of PLC and other subroutines which are pre-written by the manufacturer. However, the user cannot make any change to any of the programs written in system memory, and hence system memory is generally built from read-only memory devices. The other part of PLC memory is application memory. The application memory is divided into the data table area and user program area. The data table stores any data associated with user's control program, such as system input and output status data, and any stored constants, variables, or preset values. The data table is where data is monitored, manipulated, and changed for control purposes. The user program area is where the programmed instructions entered by the user are stored as an application control program. Well, it clearly means that the data memory stores the data associated with the user program. That means whatever is the information about the program and the data that is there with the program is stored in the data memory. The input-output module. The I/O interface section of PLC connects it to the external field devices. The main purpose of the I/O interface is to condition the various signals received from sensors, that is input device, or sent to the output devices. Input modules converts signals from discrete or analog input devices to logic levels acceptable to PLC's processor. Output modules convert signal from the processor to levels capable of driving the connected discrete or analog output devices. Here are a few examples for input and output devices. Under input devices, we can see there are toggle switches, push button switches, proximity switches, limit switches. Under output devices, we can see solenoid valves, fans, alarms, lamps, and contactors. Also, digital displays. Power supply supplies AC or DC power supply to PLC. DC power to the central processing unit, input unit, and output unit. Basically, it has an integrated SMPS which takes care of the lower operating voltages inside the PLC. Programming devices. They are used to enter a desired program that will determine the sequence of operation and control of process equipment or driven machines. There are two types of devices, programming console and computer. Well, it means these are the devices which are used to feed the user program to the PLC. It could either be done through the programming console as it appears to be in picture, or it could be done using a personal computer or a laptop. PLC communication. Well, it means how do we feed a program to the PLC? PLC can be connected to a programming device, that is, a handheld device or a personal computer through a serial communicating cable. And the recommended standard that we use is RS-232. However, this standard can be effectively used for a smaller distance, which could be as small as 30 meters. Communication can also be established with the PLC through a LAN network. That is, if at all it is required to update the program in PLC, a LAN technology can also be used. LAN, that is local area network, provides a physical link between all devices, plus providing overall data exchange management or protocol, ensuring that each device can talk to other machines and understand data received from them. If at all the distance between the PCs and the PLCs is larger, then a different standard, that is RS422 or RS485, is implemented. Well, RS422 or RS485 can be effectively used for a distance as high as 1000 meters. PLC scan cycle and speed of execution. While the PLC is running, the scanning process includes the following three phases, which are repeated continuously as individual cycles of operation. Phase 1, read inputs scan. Phase 2, program execution. Phase 3, output scan. And then goes back to phase 1. And the process repeats. In order to understand this in more better way, let's have a look at the animation.
Scanning cycle of PLC takes place in three phases. The first phase is check input status. The second phase is execute program. And the third phase is update output status. During the first phase of scanning, the status of input, be it open or close, gets updated in the input status file. During the second phase of scanning, that is the execute program phase, all the instructions get executed one by one, and depending on the status of input, the output status gets updated in the output status file. During the last phase of scanning, the output gets energized or de-energized depending upon the status of the output status table. After the last phase of scanning cycle, the entire scanning process starts again. That is, check input status, execute program, and update output status. Let's have a look at the animation once again. When the switch is closed, the information of the switch position gets updated in the input status table. During the program execution phase, the instruction gets executed one by one, and depending upon the status of the input status table, the output status table gets updated. During the last phase of scan, that is, update output status, the status of the output gets reflected in the output, and it energizes or de-energizes the output accordingly.
PLC status indicators. There are four indicators on the PLC. The first one being power on. The moment you turn on the PLC, the power on LED turns green. If at all the PLC is in run mode, the run mode LED would also turn green. However, if the PLC is in programming mode, the power on LED would remain green, the run mode LED would be yellow, and the programming mode LED would turn green. During the process, if there's any fault whatsoever with the PLC, then the fault indicating LED would turn red and the PLC would refrain from working any further. Selecting a PLC. Selection criteria for PLC is based on numerous factors like number of logical inputs and outputs. We all know that a PLC has a fixed number of input and output. However, while writing a ladder diagram, you may need extra input and output. So here the logical input and output become handy. So it is very essential to know what is the maximum number of logical input and output that your PLC supports. it is also essential to know what is the memory size of your PLC, because it is the memory where your ladder diagram is going to be placed. Besides this, it is also important to know the number of inputs and output that you would need for your project. And you should also know if your project needs an analog input and analog output, and accordingly, you could buy a PLC. The scan time is one of the most important specification of a PLC, which decides the speed of a PLC. Communication is basically between the PLC and the computer. It is the mode that your computer will use to transfer the ladder diagram into your PLC. In general, a serial data transmission is used. It could be a USB port or a 9-pin serial port. At times, even a LAN connection can be used for the same. Then comes the software. The software is expected to be user friendly, because many a times supervisors on the field are not that tech savvy. So the software should be user friendly for the user to understand and make necessary changes if required. The next that we'll be seeing is an animation of application of PLC, which will help us understand the functioning of a PLC.
This video is about an automatic bottle filling and capping unit, which is interfaced with PLC. In the video, we can see that there are 7 bottles placed on a disc groove. This disc is placed on a rotating shaft which is connected to a motor, and this motor is connected to one of the output units of PLC. We can also see a conveyor on which an empty bottle travels towards the rotating disc. This conveyor is also driven by a motor which is connected to another output terminal of PLC. Other than that, we can also notice a liquid dispensing unit and a bottle capping unit. Both these units are connected to another two output of PLC. So in all, we see that there are 4 outputs connected to the 4 output terminals of PLC. Other than that, we also have the input sensors connected to the input module of PLC. One of the sensor is connected very close to the rotating shaft. The other 2 sensors, which detect the presence of bottle on the rotating disc, are placed on either sides of the bottle capping unit. The moment the system starts, the conveyor motor starts and the rotating disc also keeps on rotating because of the rotating shaft. The moment the bottle is detected, the rotating shaft stops. So does the conveyor. The bottle gets placed right below the liquid dispensing unit. The liquid dispensing unit turns on and it remains on for a fixed time interval dependent upon the timer set in the PLC. After a fixed time interval, that is the time required for the bottle to be filled, the liquid dispensing unit stops and the rotor, that is the rotating shaft, starts rotating. So does the conveyor starts. One of the bottle gets placed right below the bottle capping unit and the bottle gets capped. In this way, 7 bottles are simultaneously filled as well as capped. The conveyor keeps moving and the empty bottle keeps coming in, and the filled bottle and the capped bottle keeps going out. This process goes on and on. This is just one unit. In an industry, there could be several such simultaneous unit which could be connected to one PLC, because one PLC can accommodate number of inputs and outputs together. Well, that's the beauty of PLC, unlike its predecessors which had fixed number of inputs and outputs, as well as the number of timers and counters in the other controllers like a microcontroller is fixed to just 2. Whereas In a PLC, you can have as many as 256 timers and 256 counters. So this example or animation gives us a detailed idea how PLC is beneficial compared to any other microcontroller in an industrial application.